Hello everyone. Uh, I would like to introduce my study for nuclear fuels presented by Yuji ARITA in University of Fukui. Okay. So the background of my study and the study fields are understanding fuel behavior during transient events and severe accidents. It's important for nuclear plant safety. So, in my field, thermodynamic properties such as melting point, phase transformation temperature, reactivity, etc., is necessary to evaluate thermal stability of fuels. So after that, prediction of basic properties is conducted by testing with simulated materials. Okay, and our objectives is to investigate the properties of new concept nuclear fuel, such as ATF, accident tolerance fuel. So what is ATF? In Fukushima Daiichi nuclear plant accident, the cladding materials is geocaloid. That is react with H2O vapor at high temperatures and making hydrogen gas. So that hydrogen gas is explored at the plant. So next generation fuel, we need hydrogen generation free claddings materials. And other type of fuels, the molten salt fuel, that is the melted salt, including nuclear fuel materials such as uranium or plutonium. That is maybe safer than the solid state fuel materials. So several types of new concept nuclear fuel. We need to investigate the properties of the fuel debris and gain knowledge of the in-core conditions for Fukushima Daiichi nuclear power plant. Okay. There are many uncertainty in the core condition at the accident time. So we need decide the temperature, pressure, and atmosphere in the nuclear power plant at that time. And the other objective are to develop equipment to enable observation at high temperatures. That means we don't have equipment to investigate at the very high temperatures such as 2000 and higher temperatures. So we need to produce ourselves such equipments. So that's our objectives. Okay. So we introduce the recent progress. Uh, at first, we investigated about the molten salt fuel, mainly chloride salt, sodium chloride, potassium chloride, and uranium plutonium chloride are used for the molten salt reactor. But many information are lack. So we need to measure the melting point, thermal expansion, density, thermal conductivity, viscosities required for core design. So the right side figure shows viscosity measurement result for the simulated materials. For the uranium is simulated with cerium or lanthanum salt. So the viscosity increases rapidly as the soil begin to precipitate. So below the melting point, some precipitations are generated in the molten salt that affect to the viscosity. So we need keep the molten salt above the melting point. Okay, another progress is about the Fukushima Daiichi nuclear power plant debris investigation. In severe accident, the molten nuclear fuel will fall, entrapping cladding and structural materials and become fuel debris. The right side figure shows simulated nuclear fuel debris produced by our laboratory. There are many phases. This metallic region is zirconium cerium alloys or cerium metallic phases, and black region are the mainly zirconium oxide. In real nuclear power plant, that is maybe uranium oxide and uranium zirconium mixed oxides and so on. Okay. So we make these simulated debris to estimate the simulation at the time of fall by studying these materials. The highest temperature is what, and element concentration is the same for the nuclear fuel, and so on. And we will more investigation to understanding the accident conditions. Okay, and the future works is the now doing the developing equipments. So we would like to develop the method to observe reactions during fuel melting in real time. So that equipment can heat up to the 3000 Kelvin. And so that we can efficiently proceed with the safety evaluation of new types of fuels. This equipment is stated in the spring weight. That is storage, link, X-ray, experimental facilities in Hyogo Prefecture in Japan. In that site, we make experiment with the simultaneous X-ray diffraction measurement and X-ray adsorption fine structure measurement under development. That is very, very difficult to measure the temperature exactly. Okay, at the last, message for students is here. Through various experiments, we will review the properties of materials, and concentration is required to be able to conduct experiments carefully. It is very difficult. Okay, but it is fun to organize a lot of data and find out new laws. So we produce many new data from the new experimental method. So that is the very enjoying point in this laboratory. Okay, we need the such as students from in the master course. Okay, that's all. Thank you.